Alright guys, Mr. Antonucci here, and we're going to go over question 1 from the 2024 AP Calculus AB free response question. So here we have a table of data, and number 1, the temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, where c of t is measured in degrees Celsius. For 0 to 12, selected values of c of t are given in the table shown. Part A, approximate C prime of 5 using the average rate of change of C over the interval 3 to 7. Show the work that leads to your answer. Include units of measure. So we want to include notation here. So we're going to write C prime of 5 equals, and then we want to show the work. The best that we can do is use the two data values that correspond to times 3 and 7 on the table and do the average rate of change. So you would have to do 69 minus 85 over 7 minus 3. And that's going to be negative 16 over 4, which is negative 4. The units would be degrees Celsius per minute. Okay, so not too bad there. We did everything that it asked for. Using a left Riemann sum, this is part B with 3 subintervals indicated by the data in the table to approximate the value of the definite integral from 0 to 12 of c of t dt. Interpret the meaning of 1/12 integral 0 to 12 c of t dt in context of the problem. So a left Riemann sum, we're going to use the table with the lower endpoints. So the first interval would go from 0 to 3. So the integral from 0 to 12 of c of t dt. The first interval goes from 0 to 3, and that would have a width of 3. Left endpoint is at 100. Plus the next interval goes from 3 to 7. So from 3 to 7 would be a width of 4 units, and the left endpoint would be 85. And then the next interval goes from 7 to 12, which has a width of 5 units, and the left endpoint 69. And then we would use our calculator to figure that information out. 3 times 100 plus 4 times 85 plus 5 times 69, and you get 985. Now it didn't tell us to include the units on that answer, but the units would be degree Celsius minutes, okay, because you're essentially multiplying minutes times degrees Celsius. Now we have to interpret the meaning of this definite integral in context of the problem. Okay, so the 1/12 is a hint that it's talking about the average value of a function. So when you have, it's essentially 1 over b minus a times the integral from a to b of c of t dt. So this would represent the average temperature of the coffee in degrees Celsius between t equals 0 minutes and t equals 12 minutes. I'm not going to write that on the screen there, but I'll say it once again, that you would write that definite integral down, and then the sentence, this definite integral represents the average temperature of the coffee in degrees Celsius between t equals 0 minutes and t equals 12 minutes. So for part C, it says for 12 to 20, the rate of change of the temperature of the coffee is modeled by C prime of t equals that function there, where C prime of t is measured in degrees Celsius per minute. Find the temperature of the coffee at t equals 20. Show the setup for your calculation. So the thing here is the table tells you the temperature of the coffee at 12 minutes. So this is essentially asking for C of 20. And that's going to be equal to the temperature at 12, which we know is 55 from the table, plus the change in temperature from T equals 12 to 20. So when you integrate the rate, that gives you the change in temperature. And since that function right there is only valid for 12 to 20, we could do the definite integral from 12 to 20 of C prime of T dt. Okay? I'm going to write our answer down here. And on the calculator, on the y equals menu, I entered the function here. It's just going to be a lot cleaner to enter it there. So then I'm going to hit math, then I did a quit out of there. You get math, number 9, that's the definite integral. And instead of you typing the whole function in, I'm going to use the variables menu. So y variables function 1. So that's just telling the definite integral command on the calculator to use the equation I put in y1, comma x, comma 12, comma 20. So that's going to give me the change in temperature between 12 and 20 according to this rate function. So the temperature decreased by 14 degrees. So at 12 minutes, it was at 55. The change in temperature was a decrease of 14.6708. So if I do 55 minus that answer, we would get, oh, no, it's 55 minus 14.6708194. When I subtracted the answer, I double negatived it. So this would give us 55 minus 40.3, or no, it's going to be minus 14.6708, which gives us a final answer of 40.329. And the units on that would be degrees Celsius. I'm just going to kind of squeeze it in there. Okay? So now part D, for the model defined in part C, it can be shown that C double prime equals this equation for 12 to 20. Determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. Give a reason for your answer. So here's the thing. C double prime is an exponential function times 100 minus t divided by t squared. So for 12 to 20, t squared is always positive. 100 minus t is always positive. And e to the 0.01 t is always going to be positive as well. So essentially, since c double prime of t is greater than 0 for 12 less than t less than 20, c prime is increasing. Thus, the temp of the coffee is changing at an increasing rate. Okay, so at the time of doing this, they've only released the questions. They don't have the actual score breakdown, so I can't tell you the point values for each question. However, I'm pretty confident these solutions are correct. I worked them out myself and then cross-referenced them with another resource, so you can be pretty sure that these solutions are correct. All right, guys, Mr. Antonucci here. Hope that was helpful. Take care.